Lesson 3.4c, Scientific Notation. A number in scientific notation is written as a product of a factor that is at least 1 but less than 10 and a power of 10. Okay, I'm going to tell you this at the top of your paper. I want you to please write this. A times 10 to the nth power. A times 10 to the nth power. That is scientific notation. Here are the rules about scientific notation. A has to be a number from 1.0 to 9.9. It's anything from 1 to 9. It can't be bigger than 9.9. It can't be less than 1. A is 1 to 9. N. N tells how many places to move the decimal. Tells how many places to move the decimal. Now let me explain something. A long time ago, scientists and mathematicians created this scientific notation because they were wasting all of their time writing out very large or very small numbers, all those digits. So they came up with kind of a shorthand, and this is the result. And scientific notation is used in a lot of things, a lot of chemistry, and definitely as the farther you go on in math, you're going to see scientific notation. Now, here's how this works. Standard form is a regular number. This A times 10 to the n, that's your scientific notation. So you're going to do two things. You're going to take a scientific notation number and write it out in standard form. So if it says 8.65 times 10 to the 7th, you're going to look at this number. It's a positive 7. So that means you're going to move this decimal that's right here, which was right here, 7 places in the positive direction. In all of those empty waves, you'd put zeros in there. So 8.65 times 10 to the 7th is 86,500,000. Okay, so let's go down to the bottom and look at an example just like that. So number one, it says 8.2 times 10 to the 1. So I would take my number that's in front, 8.2. I look at this exponent. It's a 1. So it's telling me to move my decimal 1 place in the positive direction, and you move it over here. So what is my number now, Mason?
820.
No, I moved it 1 place behind the 2. What's that? 82. Okay, 6.48, and it says times 10 to the 5th. So it's a positive 5. So in the positive direction, 1, 2, 3, 4, 5. Look at that. I've got 3 empty waves. What goes in the empty waves, Eli? 0. So I fill in zeros. And now I kind of got to clean that up a little bit. You start on the right and you go 1, 2, 3. Put your commas in. That'll make your numbers easier to read. So 6.48 times 10 to the 5th is 648,000. Now, the difference on number 5 is this. 2.36 times 10 to the negative 2. We didn't have an exponent with a negative yet, did we? So what do you think changes, Andrew?
You're going to go in reverse.
You're going to go in reverse. You're going to move the decimal to the... Not the right.
The left.
The left. Okay, so I'm going to take my 2.36, and it says -2, so I go 1, 2, and there's my decimal. What do you think goes in the empty wave, Andrew? 0, and then I would just write it away from that, 0.0236. Okay, what questions do you have about writing that out in standard form? Does it seem pretty basic? If it's a positive exponent, you move the decimal to the right. If it's a negative exponent, you move the decimal to the left. Questions? All right, we are going to go right up to example 3 now. Now you're going to write scientific notation. 76,250. You've got to do the reverse. The key is you want it to be a number from 1 to 9. Right now it's 76,000. Right now my decimal is right here. So I keep moving it over until I get a number from 1 to 9. So when I move it one place, I have 7,625. I move it another place, I have 762. I move it another place. What do I have? 76. One more place, 7 point. So that's what I want. 7.625. You don't write the extra zeros. That's trying to save time. And you count how many places you moved it. 1, 2, 3, 4 places. You moved it 4 places. If it is a whole number, a number bigger than 1, your exponent is going to be positive. If it's a decimal number, that's when the exponents are negative. If it would be example 4, 0.00157, you've got to move it over 1. It's still not, there's still a 0 on the left of my decimal. Move it again, still a 0. Move it one more time, 1.57. Now it's a number from 1 to 9, and we moved it 1, 2, 3. So it's 1.57 times 10 to the -3rd. Let's look at the examples at the bottom. Number 7, 342. 342. Right now, my decimal is right here. Is 342 a good number? No. I move it one spot. Is 34 a good number? No. I move it one more spot. Is 3 a good number? So it's going to be 3.42 times 10. How many places did I move it? To the second power. If you're ever confused about your exponent and writing it this way, I find that most kids understand this part pretty good. So just take your answer and see if you wrote it back out in standard form, if you'd get the number that you started with. Number 9, 72,300,000. I've got to keep moving it until I get to where? Where do I want my decimal to end up? Who knows? Somebody that hasn't gotten a ticket. Where do I need it? Jade? Between the 7 and the 2. So you would say 7.23 times 10. How many places did we have to move it? Jade, do you know? 7. 7.23 times 10 to the 7th. And last one, 0.081. I'm going to have to move it until I get to the other side of the 8. 8.1 times 10. Since it's a decimal, it's going to be negative. How many places did I move it? 2.